So this first question is looking at the history of the periodic table. And it wants us to identify a difference between Mendeleev's and the modern one. I think one of the key differences is in Mendeleev's periodic table, gaps were left for elements to be discovered. So he made gaps and made predictions for what those elements, what properties elements would have. Aluminium reacts with hydrochloric acid from a salt and water. Name the salt form. So because it's hydrochloric acid, we form a salt which is a chloride. It's going to be a metal chloride, and the metal is the aluminium. So here we are looking at the salt aluminium chloride forming. State the type of reaction that takes place when an acid and a base react. So this reaction is a neutralization reaction. Gallium is in the same group as aluminium. Predict the formula of gallium oxide. So because they're in the same group, we would expect it to be exactly the same format. So gallium is Ga, and we expect 2, and then oxygen we would expect 3. Gallium has got a very high melting point, and gallium oxide does not conduct when solid, but does conduct when molten. What type of substance is it? So, very high melting point and not conducting when solid, but does conduct when molten. This is describing properties that fit an ionic compound. And the last little bit, it wants us to draw the solid and gaseous particles for gallium. So remember, solid, we want them all nicely packed together in rows, no space between them. And then in the liquid form, in the gas form, we've got very few particles in the space, and the particles are spread out, and they're going to be moving very quickly. There's 1 mark for each of those correctly drawn diagrams. Give the name for the change in state labeled Y. So Y is going from a gas to a liquid. And when we go from a gas to a liquid, we're cooling it down, and that process is called condensing. And then it says gallium is a conductor. Explain how it is a conductor. So it will contain, because it's a metal, it will contain delocalized electrons, and we must always then add which are free to move. If you just remember that in a metal, we've got this kind of arrangement going on, and in between the cations we have these delocalized electrons which are free to move, and these are the cations. Okay, that's our image for us to help.